What do we always, now keep in mind here, we're solving equations. So let's get earbuds away. If anybody's got earbuds, I don't want to see any of that stuff. If we're solving equations, we're not just writing out an expression and factoring it. Factoring is part of the process, but we've got to be working with an equation every step of the way. What's the first step for this equation?
Solve for 0.
Set it equal to 0, right? I've got to put this thing, put it into a standard form where there's going to be 0 on one side and the polynomial on the other side. Which side am I going to move everything over to?
The right.
To the right. Good, because I want a positive leading coefficient, right? The biggest power of x, we'd like to have a positive coefficient. So we will go ahead and subtract 18x and add 9 to both sides, right? And that's going to give us, if we do that, we're going to get 2x cubed minus x squared minus 18x plus 9 equals 0, right? Okay, so we got this thing into a polynomial equation in standard form. Now it's got 4 terms, right? What we always want to do when we set up a polynomial equation is factor it until each of the factors has a degree of 2 or 1, right? So we can't have any x cubes in there. We need to have x squareds or smaller before we can apply the zero product property. Once we get it broken down that far, then we have the option of just setting each factor equal to 0 and solving those little mini equations, right? Give me 1 to 5 on that. Is that all making sense? Okay, good. So our strategy, we're good with the strategy. Okay, what is our strategy for how do we factor a 4-term polynomial? Okay, so we're going to do groups, right? Factoring by grouping, and then we're going to deal with each group separately. So I'm going to encourage you when you're doing this to always put a plus sign between the second and third terms, right? Because that plus sign is what separates the two groups. Okay, now from group 1, what are we doing in group 1 here, Andre? Greatest common factor. Oh, and by the way, I kind of glossed over that. But before we even started factoring by grouping, I always want to take the big polynomial and ask myself, could I undistribute something right from the beginning, right? And I couldn't this time. There was no GCF of all 4 terms. When we're factoring by grouping, I will factor out the GCF of the first group, right? We're just looking at that group. And what is it, everybody? X squared, you mean. There you go. I can factor out an x squared, which leaves me with what? 2x minus 1. Okay. And then I've got my plus sign that's separating the two groups. Now, if factoring by grouping is going to work, what has to happen in group 2? Say it again. I do, but what has to be left over when I factor it out? Okay, good. The binomial part has to be the same in both groups in order for this to work. And now the question is, we just have to ask ourselves, would that work? Is there something that I could distribute through here to get group 2? Negative 9 would work, wouldn't it? If I put a negative 9 there, if I distribute that, I get negative 18x plus 9. Check, so it worked, right? And then I'm not done. What else do I need to write on this row? Equals 0, yeah, because it's an equation, right? We're still solving an equation. Okay, now what do I do? What's my next step? Okay, good. I've got 2 groups. I'm going to undistribute from each of those 2 groups the factor 2x minus 1, right? So that gives us 2x minus 1. Now, what's going to be left behind if I undistribute that? X squared minus 9. There you go. Whoops. Good. Okay. Now, do I have to factor further here? I can, but it's optional, isn't it? Right? Because now look at my two factors. I've gotten them broken down far enough that I don't have to go any further, right? Each one of those is x squared or smaller, right? So you take your pick. I mean, honestly, I probably wouldn't factor that anymore. You could. This is a difference of squares, right? I could break this into x minus 3 times x plus 3, but I don't really have to do that. I could just set each of these equal to 0 now and solve. Once I get them down to x squared or smaller, it's optional. I can just set them equal to 0 and solve, or factor further if I can, right? If I set this guy equal to 0, what are the two steps to isolate x? Add 1 and divide by 2, which is going to give me what then? X equals, no, 1/2, right? Positive 1/2. I'm going to add the 1 to the other side and then divide by 2. So there's one solution, right? How about this guy? If I set this one equal to 0, that's a quadratic equation, and that's an easy one. It's one where I can point to a single variable. So I could isolate the x. What are the two steps here? Add 9. Okay, so I get x squared equals 9, and then what do I do? Okay, I'm going to square root both sides. Now, if I square root both sides of an equation, what do I have to include? Plus or minus. And the square root of 9 is? There we go. There's my solutions, right? Good? And again, I could have factored this into two factors, and the zeros of those two factors would have just been 3 and negative 3. Either way, doesn't matter. Okay, give me thumbs. How we doing? Okay, let's look at another one. Okay, what about this guy? Again, what's my first step always? But first set it equal to 0. Always set it equal to 0 first. So I'm just going to subtract this term to the other side, and that's going to give me positive 4x to the fourth minus 256x equals 0. Okay, what do we always, now I kind of skipped this step last time because we couldn't do it, but what am I going to do first here? GCF, yeah, could I undistribute something? 4x, there you go, perfect. So we'll undistribute our GCF of 4x, and what's left behind if I do that? X cubed minus, yeah.
96.
No. Now, if I'm dividing something by 4, I'm just cutting it in half and then cutting that in half again, right? So half of 256 would be 128. Half of 128 would be, wheels are turning, I see it, 64, yeah. So x cubed minus 64 equals 0. Okay, can I stop there? No, I can't. How come? You're right. I got x cubed. I got to keep going. So I've got to factor this more. What's the only way I could factor this one? Difference of cubes. There you go. Perfect. So I'm going to rewrite that 64 as a 4 cubed. And then I'm just going to use my pattern, right? So now we got the pattern. A cubed minus b cubed factors into what?
A minus B.
Good. A minus b times
A squared plus.
Plus. Good.
AB
AB.
minus.
No, last one's always plus, right?
God, no one.
He messed you up. I said plus b squared. There you go. Okay, good. What's our A and what's our B? A is, well, A is X and B is 4, right? A is the first thing that's being cubed and B is the second thing. So it's, instead of A cubed minus B cubed, we've got X cubed minus 4 cubed. We're just following that pattern though, right? So then we'll break this thing apart one last time. And what am I going to get here? So what goes there? X minus 4. There you go. So A minus B. What goes here? 4x, good. A times b would be x times 4, so 4x plus 16. Okay, now one quick question on this. Can I factor that purple one more?
Yeah, no. Yes.
I can't. Whenever I do, remember, whenever I do the sum or difference of squares, remember that the quadratic factor that we get is an irreducible quadratic. It's never factorable. Okay? So we can't go any further, but we don't really need to because look, I've got 3 factors which are all x squared or smaller, right? So I can, again, just apply the zero product property. I can set each of those factors equal to 0 and solve to find the zeros, right? So the first one's pretty darn easy. If 4x equals 0, what's the solution? X equals 0, right? Well, ask yourself, 4 times what is 0? 0. Okay, so there's one solution. How about that one? What's the 0 of x minus 4? If I set it equal to 0 and solve, what do I get? X equals 4. There you go. And then this one right here, I'm going to get, when I set this equal to 0, look what I get. I get a quadratic equation, right? In standard form. And we just got to go back to unit 4 on that. Well, we can't factor it. We already said we can't factor it. I can't isolate x. So what do I fall back on?
Magic numbers.
No, it won't factor, right? Magic numbers are a factoring thing. That the second part of the cube patterns, the quadratic factor, it's not factorable. You try as long as you want to, you'll never be able to factor it. So what's our ace in the hole for solving quadratic equations? Quadratic formula, right? Quadratic formula. Okay, so let's remind ourselves about that one real quick. If we've got a quadratic equation in standard form, what does the quadratic formula tell us? X equals negative b, okay? There you go. There you go. Negative b plus or minus square root b squared minus 4ac all divided by 2a, right? So we're just going to plug and chug. So for us then, what's that look like? Looks like a is what for us?
X.
No, a is the coefficient. So what's a? 1, yeah, right? What's the number that's in front of x squared? It's 1. What's b? 4. What's c? 16. Right, a, b, and c, those are coefficients. So those are always just going to be numbers. So we can solve this with the quadratic formula. I get x equals negative 4 plus or minus square root 16. B squared, so 4 squared, which is 16, minus 4 times 1 times 16. Good. All over 2. Yeah, 2 times 1 is 2, right? Okay, so then if we keep going with that, we got to simplify that. I'm going to get negative 4 plus or minus the square root of 16 minus 64 is negative 48, all divided by 2, right? Okay, I got to simplify the square root of negative 48. What's one thing that's going to happen? You're going to get an I. A negative inside a square root becomes an I outside, right? And then we got to just deal with the 48. If we make a factor tree out of 48, we can do this any number of ways, but ideally we'd like to find the biggest perfect square factor of 48, first factor, because that's going to give us a couple, right? That would work. It'd be fine, but is there a better way? Say it again. But neither one of those is a perfect square. I mean, we could do it that way. Those aren't perfect squares either. What's a perfect square? It's a number. There you go. 16 is 4 squared, right? That's a perfect square. So we'll break this up into 16 times 3, and 16 breaks into a couple of what? 4s. There you go. So I get a couple of 4s and a single 3. Couples go out, singles stay in. So then this is going to become, we know that we want to split up the common denominator too, right? Everybody get that? Because we want to be able to write this as two separate terms. That we're going to get complex numbers. We need to have a real part and an imaginary part as separate terms. So we split up the common denominator, and we're going to get -4/2 plus or minus. I got a 2 on the bottom. I get an I outside. Yeah, and what's going to happen here? Yeah, couples go out, so I get a 4 outside. 3 is a single, so that stays inside, right? And then the last thing I would do is just reduce those fractions, and I got it. So -4/2 turns into what? -2. So my other answers are going to be x equals -2 plus or minus, thank you, plus or minus. And then look, I've got another 4/2 that just becomes a 2, right? There you go. So I get 2 times the square root of 3i. There's my other two solutions, right? It's a complex conjugate pair, one for the plus, one for the minus. So how many total solutions did I get? 4, yeah. 1, 2, 3, 4. How many would I expect to get? 4. Yeah, look, we know it should be 4 because we have an x to the 4th in our equation, right? Okay. Make sense? Okay. Right, let's do one more. How about this guy? And then I'll turn you loose on this. Z equals 0, that's good. Is there a GCF I can factor out? No, there's not. Yeah. Okay, this is that other type, right?
Wait, is it no solution?
No, it's got solutions. In fact, it has to. How many complex solutions is it guaranteed to have? 4, including multiplicities, right? But yeah, it's guaranteed to have 4. Okay. What do I do with this though? It looks complicated. Can I make this look like a Unit 4 problem? Remember what our strategy is for solving 3-term polynomials. We want to see if this can be written as a quadratic trinomial. Can we make this look like a Unit 4 problem? In Unit 4, remember what we had? We had things like, instead of p to the 4th plus 6p squared, we had stuff like, our coefficients here are just 1, 6, and -16, right, in our trinomial? So what we'd like to do instead is write that as 1 times something squared plus 6 times something minus 16. Well, I mean, first of all, can we do that? What would have to go in the red parentheses for that to work? Because I've got to end up with a p. It's got to equal p to the 4th and 6p squared. So what would have to go in there? P squared. Everybody see that? Right? Everybody get that? So if I took this in packets or pieces of p squared, it looks like a regular old quadratic trinomial, right? And it's an easy kind because a is equal to 1. So this is one that if it factors, all we need to do are just find magic numbers, right? Okay, so what would our magic numbers need to be here? First of all, I guess let's do this. If I were to break this apart, okay, good, right? So we know that what has to go here and there, if when I distribute, yeah, I get p squared squared or p to the 4th. Those would both have to be p squareds, right? In Unit 4, those just would have been like x's. They wouldn't have been anything squared. Okay, so we get p squared there and there, and now we got to find magic numbers. Yeah, and what do they have to multiply to? -16. and they have to add to 6. And those numbers are 8 and -2, aren't they? Right? Okay, give me 1 to 5 on that. How we doing? That all making sense? Okay, and now, really, I mean, we're almost done. Do we have to factor any further there?
No.
Hey, Mickey, what's up? Oh, okay, I will. Yep. Yep, bye. Back you go. Yeah, okay, right. So now I don't have to factor these anymore because now both of my factors are squared or smaller. Yep. $20.
I know you need that with the teacher's salary.
That's true story. We'll talk about it. Okay. All right, so all I have to do now is set each factor equal to 0 because they're squared or smaller and solve those little mini equations. So if I take this guy, p squared plus 8 equals 0. And if I take this guy over here, what color haven't I used? I guess we'll go blue, huh? P squared minus 2 equals 0. Those are the two equations I'm going to solve to get my zeros. Let's do the blue one first. What are the 2 steps to isolate p there? Add 2 and square root, right? And how do we know that's what we're doing? Because this is Unit 4 stuff. This is a quadratic equation where I can point to a single variable, so I isolate the variable, right? P squared equals 2. So then p, if I square root both sides, what do I get? Plus or minus the square root of 2. So there's 2 solutions, right? Okay, how about this one? What are the 2 steps to isolate p there? Minus 8. Okay, good. So I get p squared equals -8. Again, I'm just going to square root both sides. So I get p equals plus or minus.
Square root of I.
Okay, good. The negative inside is going to become an I outside. And now what about the 8? If we do a factor tree with 8, yeah, you're right. It's going to be, because it breaks into 4 as a perfect square factor. 4 and 2, and the 4 gives me a couple of 2s. Got a single 2 left over, right? So that's going to give me 2 outside and 2 inside. And there's my other 2 solutions, right? For a total of 4. We got it. Okay? Give me thumbs. That working? All right. I'm going to call her quits. You guys work, get questions answered.